So in this lesson, we're looking at what we call rational expressions. Remember, the word rational just means like fraction. Ratio is a fraction. So these are fraction expressions. And you might be like, oh, I've already seen fractions. What's new about this? What's new is that these are algebra expressions that are in the form of a fraction by necessity. And why are they necessarily as a fraction? Well, because x is on the bottom. So the big issue here is, so these have x on the bottom. That's the common theme throughout this entire unit, in fact, is that x is going to be on the bottom of a fraction. And we have, the first thing that we're doing is we're learning to simplify these rational expressions. So let's recall how you simplify a fraction. When you simplify a fraction, it's, take like a fraction, for example, 3 over 6. To simplify that, what is that, by the way?
1/2.
It's 1/2. What are you doing in your head?
You're dividing
by 3. Well, but what you're actually doing is you're thinking through what are the factors of 3, and you're thinking of each of these numbers by its factors. And you're recognizing really quickly that both of them have a factor of 3, and you probably thought they're both divisible by 3, but what you mean is they both have a factor of 3. And you're finding that factor and you're eliminating it in both the top and the bottom, okay? And that's what we're doing with these rational expressions. We're finding common factors on top and bottom, and we're eliminating them. We're reducing by dividing that fraction out, or that factor out, just like the 3's there, okay? So that's simplifying. And then just to kind of get into the other operations that are going to happen here. So I guess the first bullet point here, factoring is quite a key player in this skill because of the nature of what canceling is, or what reduction is. It's canceling out common factors. We're going to have to factor the numerators and denominators independently of each other first before we can see these common factors that can be eliminated. Okay. Just remember your fraction rules. To multiply fractions, we multiply top times top and bottom times bottom, so the numerators and denominators. And then to divide fractions, we keep, change, flip. Keep the first fraction, change to multiply, and flip the second fraction. Or what was it, a phrase that I heard the other day we're dividing fractions here, and then anytime after we multiply or divide fractions, we're going to look for things to factor or to cancel out. Remember, only factors can cancel. Terms cannot cancel. Only factors can cancel. So and we'll see a great example of that right away in number 1. Last, we're going to have to restrict the domain. Okay, there is one type of fraction that is impossible, and that's when the bottom is 0. You can never have a fraction with 0 on the bottom. So we're going to, since we have an unknown in these expressions, x is unknown or the variables are unknown, we'll have to restrict that variable so that we could never have the bottom of the fraction ruined by becoming a 0. Okay? We call those restrictions. We'll restrict the variable so we can never get a 0 on the bottom. Okay, so number 1, we have x squared plus 7x over x squared. Can these cancel like that? No, because x squared on top is a term. Remember, terms are separated by adding and subtracting. And so this is a term and this is a term. Neither of those x's are eligible to cancel. We have to factor first. So let's recall our factoring methods. We always start with a GCF, and then after that we determine the next course based on how many terms. If we have 4 or more terms, that's a grouping problem, factoring by grouping. If we have 3 terms, well, I use an X chart, or you use whatever your method for factoring a quadratic would be. And then if it's 2 terms, then that's either the difference of perfect squares or the sum or difference of perfect cubes, the soap boxes. Okay, so those are our factoring strategies that we have. Quick guide for those. Any questions so far? So on this one, we're going to have to factor, the bottom can't really factor, but we're going to have to factor the top independently of the bottom. So like I'm looking at the top and I'm wondering, how can I factor that? I always start with a GCF. So if I factor out x, what is left inside the parentheses? X plus 7, right? If I factor out an x off to the side, it's x plus 7 over x squared. Now the x is a factor on the outside. That's the f part in GCF, factor. So now it is eligible to cancel. We have one x on top. We have two x's on the bottom, right? X times x. And so the one on top can cancel with one of them on the bottom, leaving one of them on the bottom behind. And so our final answer is x plus 7 over x. And we should always offer the restriction there. X cannot be 0 because that would put a 0 on the bottom of this fraction. Okay, now it's pretty obvious, like in this simplified form, that x cannot be 0 because there it is on the bottom. But there will be future simplified forms where those restrictions are not apparent in the simplified form. We have to preserve them from the original form all the way to the end. Okay. So here, let's try another one. Number 2 here, we're going to factor both sides, or top and bottom, so we can see what opportunities to reduce we have. So you know, and it should go without saying, but every single one of these problems is going to have like 4 or 5 factoring steps. So you need to be quick at factoring, right? Over. So we got x, the top factors into x.
Negative 5 and 3.
Yeah, plus 5, x minus, or minus 5 and plus 3. Right? X minus 5 and plus 3. Then the bottom factors into, it's the difference of perfect squares. It's x plus 9, x minus 9, but it's x to the 4th, so that means it's got to be x squared plus 9 and x squared minus 9, because it's x to the 4th. And can any of these break down further?
Yes.
Yeah, the x squared minus 9 can break down further. So we have x minus 5, x plus 3 on top, over x plus 3, x minus 3, and x squared plus 9. So that the difference of perfect squares. The plus one doesn't break down any further. That would only be if it was like, only the plus only works if it's perfect cubes. Okay. So here we have the 3 x plus 3's now canceling out. X plus 3, those cancel out. So I'm left with x minus 5 over x minus 3 times x squared plus 9 with the restriction that x could not be, what x value would spoil one of those factors on the bottom? Yeah, positive 3. If I put in a positive 3 right here, it's going to ruin the bottom of the fraction, right? Because 3 minus 3 is 0, and then 0 times whatever that becomes is 0. So that's no good. 3 is going to ruin the bottom of the fraction. So, and in fact, 3 would ruin it for either factor. Well, actually, never mind. 3 would be okay for this one, but it would ruin this one. Are there any other factors that would need to be restricted? Yeah. X can also not be negative 3. Why can x not be negative 3? Now, if you squared negative 3, then it would turn positive, and that would be okay. X cannot be negative 3 because x is not allowed to be negative 3 over here in the original. Okay? Remember, this is called simplifying. And when you simplify something, you're offering a simpler form of it that is still true for all values of x. You know? But this function right here, this expression is not true for the values negative 3. It's not necessarily true for the values of negative 3. Right? If I plug in negative 3 right here, what's it going to be? It's going to be 81 minus 81, which is 0. Negative 3 is a problem. It's a ruiner for this fraction. And that's not really apparent in the simplified form, is it? So I have to restrict that. I have to offer that restriction over here so that everyone knows, hey, this expression is just as good and true for any number, as this one is, except these numbers. Does that make sense? Mm-hmm. You have to preserve it. The rule of thumb is any factor that is or ever was on the bottom makes a restriction. Factors that are or ever were on the bottom make a restriction. Okay? Okay. Why don't you try number 3 on your own, and I'll show my work here, and you can kind of check along with me. Okay? As you finish up, check your answer up here. And I've given 2 different forms of the answer. Maybe at some point you have like this diehard algebra teacher, college professor or something that would want you to re-multiply these things back together in your answer. You don't have to do that for me. I'm totally fine with you leaving it in factored form, okay? But just know some teachers or some resources would want it multiplied back together. Or like if you go to take college algebra and you're doing your homework online and you have to enter the answer online, some of them are very finicky and they would only accept it in this form, okay? So, but for me, I'm okay with the factored form. Just make sure you list your restrictions for everything that is or ever was on the bottom can make a restriction. Okay, well, if you're good with that one, why don't you try number 4? If you haven't already, try it. Try number 4. Check your answer up here whenever you get done with it. Okay. Check your answer as you finish up. For this one, it's super apparent why we have to state the restrictions. Because nobody would know. If you just had x minus 4, nobody would know that negative 4 is not allowed in this expression. And again, why is negative 4 not allowed in this expression? Because this expression is a simplified form of a different one, and negative 4 was clearly not okay in the original one, so it's not allowed to be okay in this one, okay? Because we're calling this a simplified expression. Okay, so we have some multiplying problems here, but multiply problems are not really too bad. You have a couple of options. With multiply problems, if in the end, whether right away or later, we will multiply top times top, bottom times bottom. It will happen. You can do it right away, or you can do it after reducing each fraction on its own. Okay. So if you do it right away, you're following your fraction and your coefficient rule, your exponent and coefficient rules. When we're multiplying 2 monomials like this, the 12 and the 5, the coefficients multiply together. 12 times 5 would be 60. We'll put that up there. X to the 4th times x squared. We use our exponent rules. Exponents, when we're multiplying things with exponents, and their bases are the same, we add their exponents. So x to the 6th, and then y to the 6th over 2 times 6, 12, x to the 1st, y to the 5th. Okay, and these numbers aren't too bad, so it's totally fine to just bring it all together at once. But potentially you could be given 2 fractions with ginormous numbers that would be not practical to multiply top times top, bottom times bottom right away. And so in that case, you would want to do some simplifying in each fraction on its own. Like 12 over 2, well, that can simplify to 6 over 1. And x to the 4th over x, well, the x on the bottom will cancel one of them out, leaving 3 on top, x to the 3rd. And the y's, y over y to the 4th, that y to the 3rd on the bottom. So that fraction becomes 6x cubed over y cubed times, and then we have a little bit that we can do over here in this fraction. Y on the bottom takes out one of them on top, y to the 4th on top. So that would be times 5x squared y to the 4th over 6. And then we would multiply top times top, bottom times bottom. 5 times 6 is 30, x to the 5th, y to the 4th over 6, y to the 3rd. So you've got 60 over 12 obviously is going to reduce to the same thing 30 over 6 is going to reduce to. Okay. And you got your x's here, x to the 6th over x, that's going to drop down to x to the 5th right there. and then this y to the 6th over y to the 5th, that's going to reduce in the same way that these y's reduce. So you're going to get to the same spot either way, but it's just two different ways to get there. 30 over 6 is 5 over 1. And so you end up having 5x to the 5th y. You know, so the y's, these three y's take out 3 on top, leaving 1 behind. So 5x to the 5th y, and then with the, with the restriction, of course, that x cannot be 0 and y cannot be 0, because at one point, each of those was on the bottom. So somebody asked, could you cross out these 6s right here? You totally can. You totally can. You could come over here and say, like, oh, 6 and 6, but that can be a dangerous habit, because you can only reduce across a multiply. You cannot reduce if that changes to plus or minus or divide. So crossing that symbol, that operator right there, that only works for multiply. You can only do that for multiply. So just be careful if you're gonna look for reductions in that way. Okay. I think it's probably safer to instead envision a multiply dot as a connector between both. Times and times. Top times top, bottom times bottom. I think it's probably safer to think of multiplying fractions like that. Okay, why don't you try number 6 on your own and check your answer up here. If you need a hint, here's a little hint. If you don't want the hint, don't look. So there's the hint. Okay, as you finish up, check your answer there. Let me know if you've got any questions. Yeah. 3 and 1, 3 over 1. So, yeah, just before I forget. Okay, if you're good with number 6, why don't you try number 7? And then if we're feeling good after that, maybe we'll move on to division. Okay, try number 7. So on number 7, I have this interesting conundrum in the top left. Everything else factors pretty nicely, except that top left. If you are probably, hopefully, trained by now to look for a GCF, greatest common factor, and it's 3x here. You would think like, oh, just divide 3x out. And what would you get if you divided 3x out? You'd get 3x times 1 minus x. And then you would be annoyed, because you'd be like, well, I really want these to cancel, but are they the same? No, and then you might be like, well, maybe it doesn't matter. Maybe the order doesn't matter. Does it matter? Does the order matter when we subtract? Well, think about it with numbers. 3 minus 2 is a totally different number than 2 minus 3, right? So the order does matter. So I can't cancel those out. Ew, that's annoying. So to fix that, to fix the order of subtraction, you can divide out a negative, and that's what I did over here to the side. Dividing out negative 3x, and that's going to change the sign of each term because you're dividing by a negative. So it becomes negative 1 plus x, which is x minus 1. Perfect. So by dividing out that negative, I reverse the order of that subtraction, x minus. Okay, and now they get to cancel. Yay! Huzzah, problem solved. So then that becomes negative 3x times x minus 4 over 3x. And you can cancel the 3x's, but the negative stays. Just don't forget, the negative stays. So negative x minus 4. And x cannot be 0, or, looking back at the beginning, we had a few more on the bottom. 5, so negative 5 and positive 1 are also forbidden. Restricted values. X cannot be those. Okay, so I'll go ahead and stop there. You can do the other two on your own. You can check them. I'll put a completed notes online, and you can check them against there for practice. But I want to move on to division. And division is actually going to give you some more practice with multiplication, because really when we are dividing fractions, we address the division as by doing keeping the first fraction, changing the operation to multiply, and then flipping the second fraction. Okay, so this is immediately changing into a multiplication problem. And I'll go ahead and factor the first fraction since I'm just keeping that. So that first fraction is going to factor into x minus 7, x plus 3, over, dividing a 5 out for my GCF on the bottom, 5, x plus 3, times, so change to multiply, and then I'm flipping the second fraction. So here, I'll go ahead and, I would encourage you to, at least initially, go ahead and write the flipped version of the fraction before you start factoring it, okay? It's just, I totally know that you're like, oh, why don't I just factor it and flip it all at once? I just don't want you to lose points, So if you want to do that in your homework, that's fine. But if I was taking a test and test points were at stake, and if I had time, I would show that step, just so I don't mix anything up. That would be so silly and a very, annoying kick myself kind of error. So the top there, x squared minus 100 factors into x plus 10, x minus 10, over, and the bottom factors into, looks like x plus 10, x minus 7. Right, 10 times 7 is 70. And we have some cancellations. Okay, remember that multiply, that's just top times top, bottom times bottom. So really what I'm looking at here is some multipliers on top being multiplied to some more multipliers on top. Factors are just multiplying chunks. So I have these guys multiplying together, also multiplying to these guys multiplying together. Just a bunch of factors on top, all eligible to cancel with factors on the bottom. Okay, so the x plus 3s obviously cancel. The x minus 7s can cancel, and the x plus 10s. So this ends up x minus 10 over 5. X cannot be, x cannot be negative 3, negative 10, 7, nor positive 10. Why can x not be positive 10? The very beginning. Remember, the rule of thumb is any factor that is or ever was on the bottom creates a restriction. And that x minus 10 and the x plus 10, those were both on the bottom. Okay, so like the x squared minus 100, that was originally on the bottom, and that factored form of that is x plus 10, x minus 10. So right here, we've got two restrictions from that, what used to be a denominator. Okay? All right, why don't you try number 11, see how it goes. I do have an initial question, though. What is the main fraction bar? The bottom one, the darker one. Does that even matter? Yes, it totally does matter. You need to pay attention to what is the main fraction bar. Okay, you cannot just make one of them, make your favorite one the main one. It matters. Okay, all right, carry on. Okay, doing good. Finish up and check your answer up here when you're finished up, but finish it on your own first. Okay, yeah, sorry about that. X to the third on the bottom there. Okay.
Wouldn't that be an x can also be negative too?
Yeah, so it's pretty obvious when you have when you have one term on the bottom of a fraction. Well, then the variable is just the restriction is just 0. A 0 for x is a problem for this fraction. But when you have a fraction on the bottom that has a coefficient there, or a factor on the bottom that has a coefficient, you can it's not always obvious what the restriction is coming from that factor, so set it equal to 0 on the side. You're wondering, what would I plug in for x that would make that 0? Well, set it equal to 0 and find out. Okay, so you got one more in here to do if you want to for practice, and you can check it against the completed notes online. But we'll go ahead and stop the video at this point.